needs patience, Anton. It's not going to work right away. You guys need to spend an hour home with that. And I will go ahead. Please pay attention here. That was a question from Emanuela. Maybe you have the same question. She was trying to unroll all together. The meaning of isolating everything in pieces, Elsie follow that and then we'll figure out how it works personally, is to start unrolling them one by one. So I will type unroll here. Hope I didn't delete the previous one. Okay. So unroll this one, enter. This is what I get and it looks really good. Then unroll this one, the other piece. So alone, unroll surface, enter. It goes one on top of the other, so let's be careful, make sure you move them. So this is my second piece, so I have 1, 2 already. I will go for my third piece. I will type unroll again. I know it's going to go somewhere in the 0 point. So this is the third piece I have. Fourth piece, unroll. Let's see if I get any problems here. No, it looks good. And now I missed the big piece. I haven't really resolved the big piece yet. I know that this still will give me some problems. In any case, I will type now unroll. And this is the big guy. I have to move it apart. And if I wanted to be perfect, of course, what you guys will do is that since this doesn't working yet, which means the big blue piece, you will go ahead and break it in even more parts. Does this make sense to everybody? Yeah. So next step, I will move on to the next step because we have limited time, so you can follow the whole process and then we can see questions. Who can tell me what the next step could be, right? I have separate pieces. I need to find a way to glue them together. Correct, Anton? So Eric here, he created before all of these tabs. We call them tabs, which means connector points. James, Edwin, you guys, please take a look here. What I'm trying to do now is to create these tabs that will help me connect the pieces together. It's going to be impossible for me to glue pieces only using the edge point. So I need to create this extra surface that by folding will be glued to the other side. Does it make sense to everybody? Yeah. So I need to design these pieces. This is a hard process when it comes to understanding where the tabs could be, like the discussion we had before. So here in this geometry, I will go under 3D and I will say, if this is one piece, and please everybody focus on my screen, I need you to understand the logic. If this is one piece and this is a second one, Donovan, since you are very close to my screen, where would you place the tab? Where would you place a connector surface? Go ahead, stand up. Yes, I want this and this to be connected. So where would a good place be to place there a tab? Yeah, very well. So he says from this volume. Yes. Very nice. So you need a tab in the exact edge where those two different volumes meet. So this is the edge. It's obvious to everybody. So I will need to create a tab that continues this edge for the red piece, and then another tab that continues the exact same edge for the blue piece. So the inside here should have a connector point. It's impossible to come here and start gluing this edge, especially because we don't work with a very thick material. So I will need to create an extra surface from the inside part that I will glue together. Does this make sense to everybody? That's an important step, so please let me know for questions. Edwin, same? Yeah? You guys understand why we need the tab? Yeah. So let's move on. I need now to understand where this edge is, no? So I have to go back here and say this piece was unrolled and it became this one. So I need to figure out where this famous edge is. It needs lots of your time here to understand how the piece was oriented. It's easy for me because I see here those two small pieces, and if let's bring it closer. So from my screen, let me explode it just so we can see carefully. I have this small surface and this small surface. It's a matter of observation to come here and say that obviously those two are these two small openings. No? Why? Because these are the smallest surfaces in the whole geometry. So those two are definitely, let me extract, this and this. Does it make sense to everybody? Yeah? So you guys will have to spend time understanding how the unroll worked for you. A tip that I can give you, and this again a personal thing, to me it doesn't work, it makes me dizzy, but it could work for you guys. So I will just give it there, I will throw it out there, and you see if you can use it. When you unroll a surface, so let's go back and unroll the surface again. In the parentheses we said of course explode no, but there was an option of having labels. If we say labels equals yes and enter, as you see each of the edges are labeled with a number. And also in the unrolled version, which is here, each of the edges follow the exact same number.
So what is the command labels?
It's the same command. I'm doing unroll, but in the parentheses I said yes, add labels too. If I bring now those two together, and let me get rid of the previous one, and sorry I make you dizzy guys, I have to move a lot, and I come close to this small edge, I see that there is a 14, a 13, an 11, so all I need to do is to go back here and I think and see where the 12, 14 and 13 are, and kind of orient myself. I just now realize that if this is the 14 in my 3D shape is this edge. So I right away understood that this edge that is called 28, as soon as I figure out where is it here, which is this one, this is the one I want to create the extra tabs that Donovan is talking about. Does it make sense? Is it a hard process? Yeah? It's simply in the logic. I know it's hard to, to figure out what is what, but it's pretty simple when it comes to the logic. All you need to do is to understand how the unroll happened and see what is what, right? What edge is where exactly in your 3D model. So having all of that in mind, I can come here and say I know already where the tab will be. Now, the laser cut, and that's a very important step, let's all pay attention here, cannot work with surfaces. The laser cut understands only lines. So out of this unrolled surface, all I need to do is to extract all of the lines I need. How do I get lines out of this surface? Who remembers the command? That would take too much time. Right, so we're getting there. Tatiana says if I extract wireframe I will get lines, obviously, but the wireframe, Tatiana, will give you also all of the isocurves. So if I indeed extract wireframe, as Tatiana says, let's do that. Let's first explain why this doesn't work for us here. So the problem is that I got, and let me explode, that I also got this. Let me explode and ungroup. These two I don't need, right? So Tatiana says, of course, you don't need those, so you may go select your geometry, and let's select one of them, properties and say, please do not show to me isocurves. So as you all know, you can go to the properties of an object and say, do not make them visible. And now I will come here and extract wireframe, as it says, and this is what I will get. And she's right, this is what you need, right? You only need the perimeter of each of those surfaces. Now, I find that also a little bit, it needs 2 steps instead of 1. So the command we have seen that gives us only the boundaries is duplicate face border. You guys remember the command, by any chance? Duplicate face border is the command. So I need to come here, select all of my geometries. It's good that the geometry is exploded because I will get all of the edges. So I'm selecting everything and I will type select, duplicate border, duplicate face border, enter. I'm repeating, okay? So I have here all of my surfaces. I will select them and I will type duplicate face border. So it will give us the border for each of those surfaces. Yep. These are the lines I want. So let me summarize. Till now we have unrolled correctly. We have of course separated our main composition into more than 1 pieces. Then we unrolled and then we duplicate face borders so we get lines out of the surfaces because we know that the machine works only with lines. Next step. This polyline and this polyline have overlapping edges. So over here I have 2 lines, one on top of the other. This edge here is overlapping. Does it make sense to everybody? Yeah? I don't want that. The machine, if it has many lines, one on top of the other, will be confused, right? Will go again and again in the same specific line segment and will start lasering again and again the lines. So you want to create very clean drawings that they don't have overlaps. How do you get rid of that? You need to select all of your lines, explode, and these are all instructions on my handout, so don't bother writing down anything. Now, as soon as I exploded, I have the curves one on top of the other, no? That's the problem. So we'll need to select duplicates and delete the duplicates. So that's another command. Select duplicates. SELDUP. Select duplicate, enter, and as you can see, I have already my screen highlighted lines. All I need to do is to delete them. Now if I go back to my edges, I have a very clean drawing. This drawing doesn't have any lines overlapping, no lines overlap. So select duplicate was the command I used to clean up my file. So as soon as you have all of the lines and the lines are clean, no overlaps, you need to come here and do what Donovan said before, which means the tab. And Kelvin, as you said before, in order to create the tab, I need now to create from scratch a line. Okay? So I knew already that the tab happens in this edge. This specific line is the 28, as we said before, and the 28 is the edge that connects the blue with the red pieces together. I could even say that the 13 could need a tab just to have a more stable result. Again, these things are up to you to figure out how many tabs do you need, no? How many meeting points do you want per piece? So 28 and 13 are definitely possibilities for you to create a tab. So let's go ahead and manually create here a nice tab. I can very easily offset this line. So I will type offset and we'll give a distance. Again, the distance shouldn't be as big as my screen. It should be something small. So let's try 0.25, quarter of an inch. This could be good. and you have already a line, and all you need to do is to cut the line in the edge. So I could go ahead and create that, but I would propose that you guys prefer a diagonal line versus a straight perpendicular line. Why is that? Do you have any idea, Elsie? Kelvi, why is that? This is the line that is folded, right? This is the folded line. Now, we would prefer probably this line, this line versus this one, because this 90 degrees angle could give us problems of overlapping with another folding piece. So I would propose that you all go with a nice angle in the edge. You will see practically when you start figuring out the folding, you will see practically why the other one will give you problems. In any case, we will meet next week and we will see what went good and what went wrong. I'll just give you now a hint. I wouldn't go with a straight line. Feel free to do whatever you want and see the problem. So I just created a diagonal and I will trim. I will clean my shape. I need the exact same curve on the other side, so I need to mirror all the way back to the basics. I will mirror having the midpoint as a reference, and I will move that all the way in. I will trim again, and I just created a tab. This is how my tab would look like. This is one shape. It should be one polyline, so I will join back. You guys, there are 20 steps. I know it's hard, but you need to try. There is no other way, okay? You need to just figure out how all of these logistics work. For now, I want you to feel the logic of the process. I want you to understand why we're doing what exactly. So here we have one tab, and we will have to figure out where else do we need the exact same piece. So it's up to you to come and see and say, I need to now create the exact same tab for the blue piece. Make sense for everybody? Yeah? The unroll surface, no? Let's do it for another one. Here is my object. It doesn't have now any numbers. I will type unroll surface, explode no, labels yes. Unroll is the command we have been seeing today from the beginning. Unroll surface. You want to unroll the surface, and in the parentheses you want to say give me labels. So look here at the parentheses. Yeah, labels should equal yes. Okay? Unroll surface. I think that you don't need the labels, to be honest with you guys. I wouldn't add the labels. I think it's a matter of you. It's even better for you to understand how your composition works, the logistics and the structure behind what you do. So, yeah, in the end of the day, well, that's a good question. In the end of the day, Kelvi, as you very well say, this is the file you should give to the laser cut. So you won't have the labels, obviously. I mean, this you have it as a, secondary shape that helps you understand the process. But in the end of the day, this is what you are sending to the machine. You don't want the labels. So this is how your pieces should look like. Now, how do you connect this piece to the machine now, right? And what kind of material are you guys going to be using? What, again, please? Yeah, you can go with chipboard. You can go with, I propose here that you go with 2-ply museum board, which is white and it's thick and nice and it's very clean. You can go with, 4-ply Bristol board. Don't go with very thin paper because it's going to be very flimsy. So in the assignment, I give you some propositions over there. Do not go yeah, I would say 2 to 4, not less than 2 though, because it's going to be extremely flimsy. I like whiteness, so I would propose that you don't go with brown material. If you do have an argument about chipboard and brown materials, go ahead. Just have an argument because I will ask you in the end. Okay? So you will buy the material and then you will bring the material here at school. The laser cut machine, for those that haven't seen where it is yet, is on the 813 room. Have you been in this room for photographing your models? Yeah, over there is the laser cutter. So you will have to book an appointment. We'll see how you do that. You will have to bring these lines in a nice flash drive, and there will be always a person there to help you out set up your file. Okay. Yeah. Yeah. So let me finish. We are not done yet. Okay. So as soon as we are happy with this line drawing and it's clean and nice, we need to do a few more extra steps. Forgive me guys, it's a hard assignment, but we need to move on. So I will go under my layers and I will start understanding which of the lines are going to be a cut and which of the lines will be folded. As very well Kelvin said before, whatever is folded, it means that it has a different, let's say, operation. Yeah. So let's create two layers here. One I will call it cut, and the other one I will call it stitch cut. We'll see why. And okay. So I would like one of you guys to just go on top of, yeah, just stand up and show to the class where do you have folding and where do you have cut. Edwin, would you like to come over? Which of the lines mean fold and which of the lines means cut it? Just cut over there. Yeah, come over. Yeah, yeah. So Edwin just pointed out those three, this one, and you say that all of those are folded, no? Yeah, so all of the exterior ones need to be cut. They're simple cuts. What about this one? Is this a fold? Yeah. Perfect, yeah. What about this one? Yeah, you guys, you're very smart. This is a cut, of course. So I will go ahead, since I have selected my main folds, and I will go under my stitch cut. This is my fold. I will change object layer, and all of the perimeter lines, as you very well say, need to be cut. So all of those are cuts, cut, cut, cut. Is this a cut I just selected? Yeah, perfect, yes. So I will go under my cut, change object layer, and I will join them. I want them to be one polyline, okay? So join them so they are not different segment. This is one cut that the machine will start doing, so it will come here with a laser, it will start burning your material vertically, and it will cut all of these purple lines. Then the machine will come here to the green lines and will say, I want to score them, okay? I want just to give a thickness over there so it can be easy folded, yeah. All of those are foldings if I remember correctly. So I need to come here and say that these are stitch cuts. Nice. There's a cut over there. This one. Again. No, I want you to tell me, Eric. What about these ones? Yeah, very nice. So, am I good? No, I need to make them a joint polyline. Very nice. So whatever can be joined, join it, okay? So go to the layer, select all of the objects that belong to the layer and type join, so you have everything together. For everything. The machine wants to read as little as a few segments as possible. Otherwise, the machine will come here, will read the line, and then we'll do the laser, and then we'll go up again, down the other line, up again, down the other line. If you eliminate the time from up and downs by having one polyline, the machine will be faster. So you want to have polylines so you get the process to be faster. Yeah, no, join the lines. Just select all of the lines. You see how this is one. Can you guys see the screen? I know the screen. This is one join polyline, right? Before it was different segments. I just typed join in order to make it one and have the machine move all the way together. Otherwise, the machine will come here, will go down, will burn up and then down, burn up, down. Why is that? We don't want. We want the machine to come burn, 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 burn. Okay? So we maximize our time.
I think, Professor, we didn't close the window. That's why the ticket is good.
Yeah, it's a good idea. It's kind of late, but Razia, if you want to,
Close the window.
yeah.
The guy in there, I don't know why. Can you close the window so we see?
Yeah, it's not a great class, that's for sure. Okay, so let's just finish the process. I will go back to my handout. I feel that all of the process steps are pretty clear. I think that I have step by step all the things we have done for today. So any command you kind of missed is here, right? Is written down. The select duplicate command that is kind of new. The duplicate face border, everything is outlined here. Now, we are all the way towards the end. I just want you to see a little bit of the logistics. As soon as you have a ready file, you have to use the template of the school. You won't bring this Rhino file to the guy over there to help you laser cut, because the school has a policy, so the files are faster. So you...
So we use Rhino files for the laser?
Yes, you will use Rhino files. So what you are going to do is that you will click here on this link that I have under step 15. So just select Control C, or just click there, Control V, and you will go to the NYCCT Fab online website. So the school has a website for you guys to download files, to download tutorials, to take a look on many different templates. So this is the page, that has all of the machines that the school has, the blue, the gray, and the red. All of these are laser cut machines. And down here you can find the 3DM, which is Rhino file template. All you need to do is to download this template. So you just click here, you download that, and this is a new Rhino file. So you save this file, and also you schedule an appointment from the same web page. You need to go here under the link, click, and schedule an appointment. You have to log in and say what day and time you will be laser cutting, because people need to be there to help you, and also the school will need to manage the time. You cannot go all together at the same time to laser cut. So make sure you book an appointment. There are appointments of 30 minutes. It's more than enough, okay?
Am I getting a response from someone, or I just go to them and let someone do the something?
No, you won't get any response. Just book the time. You will see the time slots, whatever is available. As soon as you have there your name and you book the time, you just go there with your material and your flash drive, and somebody will be there to help you out. Say, this is me, I have an appointment, let's print it. All right? So let's see what I just downloaded. The file I just downloaded, and let's see how it looks like, so you don't get confused. I don't think you would, of course. It It's a Rhino file, and what is beautiful, what is good about this file is that it has all of the layers made for you. So all you need to do is to copy your lines from your Rhino file and paste the lines to the template. This will make also your life easier into understanding what Tatiana said before. How will I put them together? I have many pieces, I don't have just one. How will I place them together so they fit the machine? So that's the reason you guys will be using the template, because there you have all of the boundary lines that tell you where you should stick into. Kelvin, you had a question?
Yeah.
Yeah?
How long can it have to be to use the laser cut?
Right, so here, good question. Here's the template. And down you will find 3 tabs for the 3 different machines that the school have. When you book an appointment, you will also pay attention and see what kind of machine you will be using. The gray, the red, the blue, whichever is available. I cannot tell you, you know, maybe some of you print in the blue, some others may print in the red machine. Okay? Set it up under the gray, which is the one that most commonly is used. This is what I recommend. So go under the gray tab where my mouse is pointing out right now and bring this template up. You will see here, Kelvin, to your question, that there is this boundary line. This is your material. This black line is your material length and width. The bed, which means the size of the machine, is this white line. So your material cannot be bigger than that. You won't surpass anyways. It's pretty big, right? Your material should be around 24 inches maximum. 24 by 24, it's more than enough. Okay. So let's go one by one the steps now, so we finalize the process. Here are my lines. I will select the lines. I will Control-C or Edit Copy. So you want to copy these lines from your file.
Not from the top here?
It doesn't matter at all. It's not a make 2D. You just copy the files and then you paste again in a 3D file. So Control-V or Edit Paste. Now the lines will come in the exact same coordinates as they were in your previous file. So if you don't see them, it means that they are very far away from the bed. For that reason, I propose that your lines are very close to the 0, 0. Why? Because I know that the laser cut template starts from the 0, 0. If your lines are very far away, you may have trouble locating them.
Can you just move it?
Yeah, I will now move them. Now they're outside of my bed, so I will have to select them and type move from any corner and make sure they fit inside here. Now this is your material and you want to economize the material. You don't want to spend the material. So make sure you go close to the edge, but do not touch the edge. You don't need to go and say touch the edge because the machine may have some problems. Leave half of an inch maximum over there. So move it so it's almost close to the edge, but it doesn't touch. I would say that this distance is quarter to half of an inch. Okay? Not more, not less. So this is how your file should look like when you give it to the person to laser cut it. This is the template. Make sure you don't exceed, make sure that this is not out of your material. The person will help you there. If the person sees something out of order, will let you know. They won't waste, of course, your material, but try to be efficient with their time, okay? Now, I'm practically done. All I need to explain finally is how you will make use of their layers. When you copy pasted, you brought inside the 2 layers you created. So this cut layer and the stitch cut layer, these are my layers, the one I created in my file. Since I have been given such an explanatory layer default, I will use it. So I will go ahead and I will select all of my stitch cut lines. So I will right click and say select objects, and I will move them wherever the stitch cut happens. So I will go under the cut operation and I will go and say this is my stitch cut, select, right click and change object layer. as you can see now, this is how the folding looks like. There are dust lines. I will move on, I will go under my cut layer, I will select all of my objects, and I will move them under the cut, inner or outer. Why is that?
It has to be both because you have to
What you're trying to say, Elsie, is very smart, but let's see if indeed we have both conditions here in this file. For now, we'll move it under the cut outer, so change object layer, and I know that this is under the cut outer. Okay, if my composition was something like that, then I would say that I have an inner cut and an outer cut. The outer cut, of course, is the big perimeter, and the bigger cut is this one. So this is a big hole. Yeah, so I would say that this is an inner cut and this is an outer cut. Why the machine needs to know that? Who can imagine why we need to know that? Elsie, yes.
because the machine wants to like cut the outer layers first, so then you go into the inner. If you don't like layer the inner layer, that's you only will cut like outer layers.
Again, Eric? Well, even if I had those two under the outer cut, the machine would work perfectly. The problem is that, imagine that we said to the machine, this is an outer cut. Okay, the machine would say, I will come here, and I will come here and I will start cutting. This is an outer cut, this is an outer cut, I will start from wherever I want. The machine starts, cuts this shape, okay, and then comes here and cuts this shape. And then you take that shape out. Now, if the machine does the opposite, says, I will start from here, I will cut this out, and then I will go to the big scale. What do you think is more stable to happen? If you had to cut that by hand, would you start from here or from here? The inner Donovan, why is that? Exactly, because your cutter wouldn't be stable, the material wouldn't be stable. If you cut first this guy, then this kind of moves around, no? It's not stable anymore. And then you have to come here and cut this one, which means you add a little bit of pressure, and then this moves and things get hard. The machine is machine, but it's not perfect. So let's make the machine's life easier. If you had to cut that by hand, you would definitely start from the inside, and then you would go to the outside, just for this to be stable. So always we need to say to the machine, where's the inner, where's the outer, and then move on. So in this case, Elsie now, your point, do we have inner and outer? Mhm. Outer cut, but I don't think we have an inner one. The machine will start here and do this one polyline, and that's it. So we only have an outer cut, and then we have this stitch cut.
What about those two?
Yeah, they're both outer cuts.
Those two are also outer?
Yeah. So
One doesn't have an inner cut though.
this whole thing and this one, they are both outer cuts.
But it's weird, can't you machine inner or outer?
No, because the rest can be folded, so they have to be outer. I can see that.
You guys, even if you place everything in outer cuts, it's going to be fine. It's just going to take more time, and we need to start now understanding what we are doing, right? It's not that we give a file to the machine and it's going to do everything. Let's understand. Not a big deal though, even if you place it in one. I want you to have in mind though the differences. Okay, final thing, and I'm going to leave you alone. Why do we have stitch cuts instead of scoring? So in the beginning, I think it was Donovan that he said the folding is a score operation. It's basically if you had to fold a thicker piece, let's say this, forgot to do that. Okay, next one. So if you wanted to fold that, which has a substantial thickness, you will take your cutter. If the folding was toward this direction, you will take your cutter and you will start cutting here, but not all the way to the thickness material, right? Just halfway. And then you will be able to fold that easily. Mhm. That's a scoring operation. This is what you do with your cutter. You score. Now, the machine has one-way score, as you can see, which means that your foldings should always happen from the same side. This folding is very different than this folding. If I had to fold this direction, I would have to flip my material by hand and score here and then fold. So the direction of my score is very important. Now, because again we have very limited time with the machine, only half an hour is your slot, and you want to make your life easy, you won't say, okay, let's score and then let's interrupt the machine, open the bed, flip the material and score again on the other side. Because you have foldings in many different directions. For that reason, for this class, we'll use the stitch cut. So the machine will come here and will say, whatever is blue, I will cut all the way through. So I'm cutting the material. Whatever is fill, right? I'm not cutting anything. So the machine will cut all of the blue lines and then the rest will not be cutted. So the folding will be okay with both directions. Mhm. Now, I wouldn't recommend you do that if you're laser cutting something super thick like plexiglass. This wouldn't work. You would have to score. But for our, which we're going to be using crystal board, or as we said, the resin board, two-ply resin board, then this is perfectly okay. So let's do that as a class. Okay? Yeah? Personal question. So we're done. For next week, I want you to, of course, read carefully. I will upload these recordings. They're going to be pretty lengthy.